Rate of Reactions Part 2, in which we'll be discussing the past papers. The first one reads, a group of learners used the reaction of excess hydrochloric acid with magnesium powder to investigate one of the factors that influences reaction rate. The balanced equation for the reaction is. Once reading that, I would write down the factors that influence the reaction rate, which we've done in the previous videos. They use hydrochloric acid of the same concentration in X grams of magnesium powder in each of two experiments, 1 and 2. Both experiments are carried out at 20 degrees Celsius. We know that the concentration is the same and the temperature is the same. The graphs are shown below. However, curve 1 is incomplete, so the bottom one is incomplete. Define reaction rate in words. This is something you get from the guidelines and you just have to learn it or by heart it. Calculate the average rate of reaction for experiment 2 for the time interval 30 seconds to 60 seconds. We just have to read the graph. At 30 seconds, we can see it is approximately 65, and at 60 seconds, it's approximately 105. Now let's look at the answer. We see that it's 104 and 64. In this case, in the model answers, there will always be a leeway, either 1 on each side or 2. So we don't have to worry about that. Which one of the experiments, 1 or 2, took place at a slower rate? Give a reason by referring to the graphs. The answer is experiment 1 because there is a less steep gradient. So, the steeper the gradient, the faster the reaction rate. Please make a note of that and write it down. Write down the factor responsible for the difference in the rate of reactions. We know that the concentration is the same, we know the temperature is the same, and most likely the magnesium powder is the same. So there is another factor which is a catalyst. Use the collision theory, fully explain how the factor in 5.4 affects the rate of the reaction. So in the previous videos, I taught you how to answer it exactly, but let's have a look at this one. A catalyst provides an alternate pathway of lower activation energy. More particles will have sufficient energy for an effective collision, and the number of effective collisions per unit time increases. Thus, the reaction rate increases. Calculate the mass of magnesium powder remaining in the container at 150 seconds for experiment 1. Take the molar gas volume to be here. Let's look at the marking criteria. You first use the formula N equal V over Vm because they gave you the molar gas volume. Now you take the 24040 and convert to dm, which will give you 24,04. Now we worked out the number of moles. Now we take the number of moles and substitute it in the formula m equal n with times by capital M, and you simply just solve for your mass. The next one reads, study the following chemical equation. Use the above equation and draw a potential energy diagram. Label the specific reactants and products as well as the activation energy and heat of the reaction. So the activation energy is the top part and the heat is the difference between the products and reactants, which is labeled here, and you literally just take the reactants and the products from the equation given. Define the term catalyst. This is something that you have to also learn from the guidelines, but you can read it on the side if you want to. The following table shows two catalysts that can be used for this reaction and their corresponding activation energies. Which catalyst, platinum or osmium, will be more effective for this reaction? Use the collision theory to explain the answer. Platinum is the lower one, and osmium is the higher one. So it would obviously be platinum because a catalyst decreases the activation energy by providing an alternate route for the reaction to take place, and that is the lower one. Thus, we use the platinum. The lower the activation energy, the higher the rate of reaction. More particles will have kinetic energy that is greater than activation energy. Let's have a look at the last past paper example. The collision theory can be used to explain how different factors affect the rate of the chemical reaction. Name two conditions that determine whether a collision between two molecules A and B will lead to a chemical reaction. The correct answer is correct orientation and sufficient kinetic energy of the molecules. The following graphs show two identical reactions taking place at different temperatures. You can see T1 and T2. In terms of the collision theory, explain why the chemical reaction increases with increasing temperature. We have done this in the previous video, so I'm hoping by now you should know. Higher temperature causes an increase in average kinetic energy of the reacting particles, or the more molecules will have sufficient kinetic energy. Which graph represents the reaction taking place at a higher temperature? Write down T1 or T2. We know that it is T2 by just looking at the graph. What is represented by the total area under each graph? The total amount of the molecules or the particles which can take place in the reaction. That is what is represented. What is represented by the shaded area under both graphs? That is the total number of molecules with kinetic energy higher than the activation energy.